Hello and welcome to this Introduction to GIS tutorial on installing and importing data. Basically it's a quick start guide to get you going with QGIS. In this tutorial we'll be covering why QGIS, briefly how to install it, a bit about getting data in a variety of formats, saving your map, and then we're going to talk very briefly about coordinate systems and some traps to avoid. It's going to move pretty quickly. This is not going to be in depth, but it's hopefully a guide that will get you going. So why QGIS? QGIS is a full-featured GIS package. It's open source and it's free, which is really cool. But why use it when you've got other things out there like Google Maps and Google Earth, or CartoDB, national maps if you're from Australia, or Aperture, which is kind of a transport portal. And these are all web-based mapping solutions. And I guess the main reason for me is that it's just a much more powerful piece of software. There might be a bit of a steep learning curve at the start, but once you've mastered a few of the basics, you can really just do so much more with it. Geoprocessing, joining layers, all of that sort of thing. But it also accepts many different formats. It's free, which is great. The downside is being open source software, it can occasionally be a little bit buggy. Okay, installing QGIS. So just head on over to QGIS.org. I've already got that opened in a browser here, sorry, this one. And from there, all you need to do is go to the Download Now link and select the appropriate version for your platform. We've got Windows, OS X, Linux as well. And I would recommend you install version 2.18 for now. It is the long-term release and most stable one, and if you're just starting out, that's probably the best place to begin. There's also a 2.18 version for Windows as well. You'll know if you need the version 3, the latest and greatest one. So you can just click on the relevant link and that will download, and you can install that as per normal. So version 2.18, if you do already have it installed, you may need to remove any previous versions. Once you've got it installed, you can open it up as you'd normally open an application. You'll be looking at something like this. You can just go to Project and New, and we're ready to go. So the first thing I wanted to go through is to bring up a base map. So we're going to go to Plugins and Manage and Install Plugins. And depending on your internet connection, this can take a little while. Sadly, I'm on a fairly slow one. Alright, so these are all the plugins that you can install for QGIS, and the one that we want for this is called Quick Map, or Quick Map Services. Now I've already got this installed, but once you click on it, there'll just be a button down the bottom that says Install Plugin. And after you've got that installed, you're going to have these two icons in the menu bar, and under this web menu, you're going to have Quick Map Services. So bringing up a base layer is as simple as going to something like OpenStreetMaps here. A lot of these other layers aren't great for Australia, which is where I am, but OpenStreetMap has pretty good coverage worldwide, and if I click on OSM Standard, I have a map of the world. So I'm just going to use the scroll wheel on the mouse to zoom in. It's one of the best navigation tools for in QGIS. And zoom into Melbourne, which is where I live. So just to orient ourselves a little bit, we've got our map window as the big window here, and over on the left there's the layers panel, and you can see there that's where the OpenStreetMaps layer is, and we can switch that on and off there. There weren't a lot of layers that you could see in that menu that you can also get to from here, but with Quick Maps you can also search for other layers using that search button. You can see a few of the ones I've looked at recently, but let's just do the search again. So if I just type Google in there and wait for a little bit, it's doing a web search to look at layers that it can bring in. And here we go, we've got a Google Maps layer here. We've also got a Google Satellite layer. We've got that one here, and we've got the hybrid, we've got Google Terrain. So I'm just going to add the Google Maps layer, and I'm also going to add a satellite layer as well. Now, you may have noticed that we can't see them, and if we look over at the Layers panel, we can see that Google Maps and Google Satellite have showed up under the OpenStreetMap layer. So if I switch OpenStreetMap off, then we see Google Maps. The other way to do this is you can also reorder by dragging, and now that Google Satellite is above Google Maps, we can see the satellite image. So I'm just going to switch those two off, and there's one other that I will mention, no, more than one other. Esri are the makers of ArcGIS, which is kind of what QGIS is modelled on, and they have a lot of these background layers that you can use. So if you just type in Esri, you can get to those. But one of my other favourites is this one called Positron, because it can make a really great background when you don't want a lot of detail. It's this nice faded out background. So that is getting a background layer in. So we installed the plugin, we pulled up a background, and we also, from the menus, and we also searched for a background. There's another layer called Open Layers, another plugin called Open Layers that does a very similar thing, but I tend to prefer Quick Maps service. But if you have troubles with that, you can always check out Open Layers. So the next thing we're going to do is bring in a shapefile. So the first thing we're going to do is go and download that from data.vic.gov.au. We're looking for the VicMap transport layer. And I really love data.vic.gov.au. There is a huge amount of information there, but it can also be a bit tricky to find the information that you need. But anyway, after we dig through a few menus and find the layer, we've got to enter our email address and select the region we want to download that data for. So we're looking at the transport layer, and I'm going to use the city of Whitehorse as a little example. Then we submit the request, and you get a link emailed to you to download. So once you've downloaded that file and unzipped it, we can go and get that data. So this panel over on the left is our probably the best way to import layers. So this top one is what we want for our shapefile. We're going to go browse. Now this is the zip file we downloaded, and this is the folder that we extracted. And unfortunately, we've got to go through a lot of folders to get to our shapefile, and this one is not it. We've got to go one more folder down, and the download I request was for a number of different transport layers. We've got air, rail, road structures, but what we want to bring in is road. So these 4 files here make up a shapefile. Anyway, sometimes you have 4, sometimes you have, I think, up to 6. But the one that we want to use to import them is this .shp file here. So we can click on open, and that has imported our road layer. Now we can't see it right now, so what we're going to go do is go zoom to layer. And there is our data. Cool, so those are the roads. To make this a little more useful, we're going to have a quick look at changing the style. So if we double click on this and go to style, we can straight out change the thickness of our lines in this layer. We can also change the color of the lines, and when we come back, they look a bit different. Data is what makes GIS so powerful. So not only do we have this map of the roads, but there's data attached to each of these lines. And we can look at that by looking at the attribute table here, which has things like road name, and right down here it's also got whether the road's sealed or not. Where's the one I'm looking for? And we've also got the class code here, and we're going to use that to style this road. So if we double click on it and go to style, go to categorize, and we're going to use the class column. Class code, and we're going to click on classify. And right now it's allocated a different color to each of our roads. So we're just going to hit apply, and if I move this window to the side, we can have a quick peek. And so we have a different color for each class of road. So it's starting to give us a bit more of a picture of what's actually going on. But these different levels of the hierarchy actually mean something. And so I'm going to use a few predefined styles because they're nice and quick. They're really not my favorite styles, but they can be kind of handy. Tertiary road, secondary road, tertiary road, and let's do something like that. And we're going to make this one the same because I'm running out of classes. Okay, let's hit OK and see what we've got. So we can see along the top here we've got a freeway or a motorway, and then we've got a couple of arterials in orange. Let me just get rid of that. And then we've got our lower level classes of road. If I hit this triangle, we can see them all at once. Now, I know that class 6, I think, is private roads, and 11 and 12 are bicycle tracks. So that there is our road network. What else do we have to say about this? That was the other thing. We can pull up one of our background maps and see how it looks. Now, if you recall what the Google Maps looked like earlier, we'd expect to see roads behind this one, and that brings us to one of the problems that you can run into with GIS, and that's coordinate systems. So we're going to talk more about them at the end, but for now, if you go to Project Properties, and down on the side menu to CRS, we're going to enable on-the-fly transformations. And we're going to hit, leave it in WGS 84 and hit OK. Now, our road layer is moved, but that's all right. We're going to zoom to the layer again, and with a bit of luck, we both have our backing map and our City of Whitehorse road layer, and they overlay each other and match up just nicely. So that's your easy fix for that little problem. Alright, let's clear those out and go back to our slides. So shapefiles, they're an Esri proprietary format, but it's become a bit of an industry standard. They're nice and fast when you're loading them in GIS. It's a very common format, and you can do multiple geometry types. We just loaded a line file, but you can do polygons, you can do a variety of different lines and paths, and you can do points as well. The cons are that you end up having these multiple files per GIS layer, which can make them a bit unwieldy to manage. You also can have header restrictions. There's a character restriction on any of those column headers. Anyway, there's your link to download the data at the bottom. So the next file we're going to look at is a CSV file. I'm just going to close this up. So the CSV file we're going to use comes from data.melbourne.vic.gov. So it's the City of Melbourne. And we're going to use their on-street parking meter locations. So CSVs are a really nice, handy format. So to import CSVs, we use this button down here in the side panel, the delimited text import layer. And once again, we can just browse for our layer, and there's our on-street parking CSV. We can go open. Now, just below this, we have our file format. Now, we've got CSV, so that's nice and easier, but you can also do custom delimiters like you might have when you import into Excel. Our first record has the field names, so that box needs to be checked. We are importing point coordinates, and this is where we potentially need to have some input. QGIS will try and pick which columns have our location information, but sometimes you need to select them manually. And here our X field is longitude, and our Y field is latitude. And we can have a quick look to see if everything looks right and preview our data, and we're going to click on OK. There's just a little warning saying that we need to define a coordinate system. But I think it's picked the right one anyway. So if we're going to zoom to that layer, and there are our parking meters. Once again, we can pull up a base map, and I'll use the positron one now. And fortunately, that lines up over Melbourne. So we've got everything in the right place, which is really nice. I showed you before how to look at the attribute table, but one other way to look at data is using the information button up here. So we can click on the information tool and go and click on one of our points, and we can see that this parking meter is on Flemington Road. There's some information about the asset ID, the barcode number, whether it accepts credit cards or not, and our location information. So again, we can style this up to make it look a bit nicer and give us a bit more information. So we're not going to worry about changing the size. We're going to go straight to categorizing them. So one of the ways we can look at them is look at meter type, and we could classify via random colors. We've got quite a few different meter types there. So let's just apply that and have a quick look. And you can see where around Melbourne all different meter types are. And you can see a few patterns there, which is kind of cool. But I think most of us don't really care what meter type we've got, but what would be helpful to know is whether you can use a credit card. So let's reclassify. This is just saying we want to overwrite. So we've got a yes/no answer as to whether we can use a credit card or not. And I'm just going to change this color to be a bit, let's make yes green and no red. Okay. And we're going to click OK. And let's bring up a base layer again so we actually have some contextual information. So now we can see which parking meters we can use a credit card for, and the base map tells us where that meter actually is in context. This zoom button here can be really handy to go in and have a closer look. And there are our parking meters. Excuse me. So let's go back to our slides. comma-separated text files are very common. They can be plotted on a map if they have spatial coordinates like we had there, Latin long. So they're very common. They can be created and edited with any text editor, but also things like Excel, and you can output them from Access, and just about any software and website that gives you downloads allows you to use CSV, or often gives you a CSV option. They're very robust in terms of longevity because you can view them with any text editor. On the downside, they tend to be a bit slower to load in QGIS. You tend to only do point geometry. You need to know a bit about projections, and they can't be used for some geospatial operations, but we'll deal with that in later tutorials because there are ways around that. And there's a quick link to our data down the bottom. So let's switch those off and go and get the next data source. So the next piece of data, or the next type of data, is geoJSON, and we're going to use the Shepparton City Council Street and Park Trees dataset. To get that, we need to go to data.gov.au, which is the Australian National Data Repository. As you can see, there are lots of formats that you could download this data in, but we picked geoJSON just so we can show you another format. So JSON is a text format, but despite it being text, we still import it with this vector import function or button. Okay, so we need to back up out of where our shapefile was, and there's our City of Shepparton layer. So we just go open, open. Now, once again, we're not looking at the right portion of this map, so we're going to use the zoom to layer function, and those are our trees. Let's quickly bring up Google Maps. And if we toggle that layer on and off, we can see that the trees that we have a record for are typically in the towns. And they're obviously very tightly packed because they just come out as a big blob from a distance. So there are our trees, and we can go and have a quick look at what data we have to go along with our trees. So this particular one, we've got a genus and a species. And we've got the common name down near the bottom. We've also got some information about the size of the crown and the height of the tree. And so, like I said before, there's all sorts of things we can do with that data, which is the advantage of using a GIS system rather than something just like Google Maps. So let's style this layer up as well. Now we're going to start by changing our marker. I should just mention that this window might look a little bit different to what it normally does for you because I've changed my resolution to make this a bit easier to see. But anyway, we're going to go from a simple marker to an SGV marker. And normally you would see all of this part together. So we're going to find an image that works well with our trees. Now, I can't remember exactly. There it is. That one. We're going to use a tree to represent our trees. So this little cross up on the right here is our preview, and you can kind of see that that isn't quite going to work. So let's make it a bit bigger, maybe a bit bigger again. Okay, that's a bit better. And we're going to center it. Okay, that's good. And now let's just hit apply and check that that looks right. So I might have gone a bit too big, so let's bring that back to 5 and go OK. So we now have trees to represent our trees, which is kind of appropriate. But we can do a bit better than that. We can jump back into this style and we can choose the categorized option. We do want random colors. That's the column we want. So the genus could be an interesting one to use. So let's classify that. We've got quite a lot of genuses, so it's not going to be super clear, but we might still be able to see some patterns. So let's hit OK, and let's switch off Google Maps and put that grey background image back up. But quite quickly, you can see some patterns, and some trees are favoured on the street over others. So let's zoom in with the scroll function just a little bit. The downside of using the quick map layers is you've got to reload from the internet every time you zoom. So we can see we've got a honey locust on the nature strip all down along here. And then what are these purple ones? These purple ones look like they're spotted gums, and it might not be all the sort of pinky purple magenta ones, because we have so many options in this list, but it certainly helps to identify some patterns. Lipstick maple. Now, if we have a quick look at the Google satellite layer, we can also check to see whether our trees line up with our satellite image. And it looks pretty good. Down along here you can see each of the trees, which happen to be weeping willows, and they line up pretty well with the GIS data that we've downloaded. Okay. Cool. So, geoJSON data. JSON formatted files are really common. It's a text format that's designed to be easy to read for humans and computers, and is often used for web-based data transfer. It's a very common format. It can produce multiple geometry types, and being text, it's fairly human readable and easily editable. Again, it's a bit slower than shapefiles, and it tends to produce a larger file size than CSVs. And there's a quick link to the data we used for our trees layer. Alright, next data source. Let's switch those off. And you can see that tree's still there. If I just click that information tool on nothing, it disappears, in case you're wondering what that was. Okay, our next data source is KML. The data that we're using for this particular one was a GPS trace from a hike I did in Wales a couple of months ago. So we're going to add a vector layer and breckenswalk.kml. And open, and as it turns out, I've saved two different geometries in this file, but we're only interested in the line string. So we're just going to hit OK. And when we go zoom to layer, we'll be transported to the other side of the world, hopefully. There it is. Okay. So there is the walk I did. Now, again, let's look at the attributes table this time. There are not many attributes listed with this one, and we only have one item of geometry, and there's no description. So that's pretty simple. We don't have much to color it on, but I think we are going to tweak it just a little bit. So we'll make that line a little bit bigger, and let's go for a bright orange line. There we go. So rather than bringing up one of the backing maps before, I'm going to skip ahead to the next item of geometry, and that's a raster file. So a raster is often an image, so it might be a satellite image or a map or something like that, And so what we're going to do is we're going to bring in a map that I actually created so that I could do this hike. I pulled in data from the British Ordnance Survey and put it all together, styled it up, and created a georeferenced map that I could use on my phone to navigate. Now, for some reason, it reproduces pretty poorly here, so I discovered a little tweak while I was working on this that makes it just a little bit better. Not much, but just a little bit. So we can see that a bit better now. So the walk started in Crickow, and it followed through town and up the hill, walking beside a creek, and sometimes, I think it's this bit here, you're actually walking in the creek, and all the way up to this little mountain here called Table Mountain that overlooks Crickow, and it's actually an old Iron Age fort up there, so it's really cool. And it was a lovely walk that I took lots of photos on. So there is importing a KML and a raster. So let's just quickly go back and summarize those a little bit. So KML. KML stands for Keyhole Markup Language. It's a format that was largely brought into the public sphere by Google. It's what they export from Google Maps and used for that for a long time. It's an XML format, which is again another one that's designed to be both human readable and computer readable text format. It's quite common. You can do multiple geometry types. Again, human readable, easily editable. The downside is that the attribute data attached to a KML can be a bit hard to deal with GIS software. It can be a bit hard to get access to that sometimes. And again, it has a slightly larger file size than CSV. And then raster. Like I said, raster is quite often an image, but it can also be gridded data values. So sometimes if you want to show temperature across all of a country, you'll actually have a gridded data value where your position in that matrix gives you your spatial location, provided it's all overlaid correctly. So raster files can be really helpful. And we use the georeference recreational map that I built. So saving your map, a very simple but very important step. So if we jump back into QGIS, we can go project, save or save as, and where am I going to put this? Video 1. That's what we're working on now, and I'm just going to call it intro map and save. So the really important thing to remember about this is that this has saved all our settings in QGIS. It hasn't actually saved any of the data layers. Those data layers still have to exist in that folder, and if you move them in that folder, then QGIS won't know where to find them. There are ways to reline them up, but it will mean your map won't work, at least initially. So all these different data layers haven't actually been saved, they're just being referenced, so they still need to exist if you want to keep using the map. Next, we're moving on to coordinate systems. So coordinate systems are kind of a bit of a big scary topic, and there's an awful lot that can be covered, but I want to give you just a very few quick tips because you've already seen that they are quite important to the process. So there's two main types of coordinate systems, and that's geographic coordinate systems and projected coordinate systems. So geographic coordinate systems try and model the world as a sphere, or something close to a sphere, and all the coordinates that you have are in latitude and longitude, or degrees, minutes, seconds type of variable. So it's a spherical coordinate system. It's good for large areas and data provided with latitude and longitude, But one of the key things to remember is if you're working with distances in a geographic coordinate system, your distances are going to be in radians, which quite often isn't a very practical system to work with for most people. So for projected coordinate systems, often you'll be specified with an X and a Y. Sometimes it's not that obvious, but quite often that's a distinguishing factor. For geographic, it'll be lat and long, or latitude and longitude, and projected will be at X and Y. But it tends to be better for smaller areas because when you try and flatten out a sphere into the rectangle like you see there, you have to stretch things or cut things or shuffle it around. So the areas close to the poles on that rectangular map have been stretched significantly, and the areas aren't really representative of the actual areas. And you run into distances with issues with distances. But what they are really good for is that you get your measurement units in meters or kilometers or miles or whatever the actual coordinate system you're using uses. But it's everyday units that you might use. So it's really good for printed maps. And so that map I created of the National Park in Wales, I used a projected coordinate system to do that so that my grids were in meters or kilometers. Now, the really important thing to do is try and keep all your data in the same spherical or projected coordinate system wherever possible. You saw that we could click the on-the-fly coordinate system adjustment button, whatever that was called again, to be able to get those coordinate systems to work together. But when it comes to joining data and selecting one layer with another layer and things like that, it becomes really important that they're all in the same coordinate system. But let's just go back and I'll show you a few bits and pieces. So we're in the project properties and we enabled on-the-fly CRS, Coordinate Reference System Transformation. We had it set up with WGS 84, which is a geographic coordinate system. It's one of the spherical systems. GDA 94 is a great one for Australia. Excuse me. The British National Grid is what I use for Britain. These Vic grids and MGAs are ones I often use for Victoria. But if in doubt, WGS 84 is a great one to use. Okay, so thanks for listening. If you're interested in more of my maps or visualizations or ramblings about data, I've got a blog called Maps and Graphs at mapsgraphs.blogspot.com, so go and check that out if you're interested in seeing more of that. I will find a way to post these slides online so that you can get all those links and review anything you missed. Hope you enjoyed it, and I'll see you next time. Thanks.